All right, now let's solve some second order ODEs like y double prime plus 5y prime plus 4y equals 0. And the upshot is, in order to solve those, you just need to find the roots of the auxiliary equation. So here the auxiliary equation is r squared plus 5r plus 4 equals 0, which you can factor out as r plus 1 times r plus 4 equals 0, which gives you r equals minus 1 or minus 4. And then, based on what we discussed in the previous video, the solution is just a e to the minus 1t, so minus t, plus b e to the minus 4t. But again, the real reason this works is because of the factoring method. Now let's do another example using initial conditions. So let's solve y double prime plus y prime minus 6y equals 0 with initial position 2 and initial velocity minus 1. So just as before, we need to factor out the auxiliary equation, which is r squared plus r minus 6 equals 0. Again, the product is minus 6, the sum is 1. So that works for 3 and minus 2. And so r is either minus 3 or r equals 2, which gives you the solution a e to the minus 3t plus b e to the 2. And that is y of t. And now all we need to do, we need to plug in the initial conditions to solve for a and b. Just like before, we solved for c. So now y of 0 equals 2. That tells you a e to the 0 plus b e to the 0 equals 2. So a plus b equals 2. So b is 2 minus a. So keep this in mind. Keep that in mind. But now let's go back because we want to also find the derivative. So using y equals a e to the minus 3t plus b e to the 2t, let's calculate y prime of t. So using the chain rule, it's minus 3 a e to the minus 3t plus 2b e to the 2t. And so y prime of 0, in this case, it's minus 3a e to the 0 plus 2b e to the 0. And that's minus 3a plus 2b. But now, if we want, you can use the fact that b is 2 minus a. So again, 2b or not 2b. So minus 3a plus 2 times 2 minus a. And you'll see this simplifies. So then we get minus 3a plus 4 minus 2a. 2a. And so this becomes minus 5a plus 4. But remember, y prime of 0 is minus 1. And so we get minus 5a is minus 5. And so a is 1. A is 1, and b, which is 2 minus a, it's 2 minus 1, which is also 1. So b is 1. And so in the end, what is our solution? Y is 1 e to the minus 3t plus 1 e to the 2t. And if you're curious what the graph looks like, it's quite interesting. So it looks like a parabola, but it's not. Strictly speaking, it is a hyperbolic function. Like think in terms of Cauchy and Sinh. And last but not least, what I wanted to mention is the cool thing is everything we learned today about second order ODEs actually also applies to higher order ODEs. So if you want to solve the following, y triple prime minus 6y double prime plus 11y prime minus 6y equals 0, you would still find the auxiliary equation, which is, in this case, r cubed minus 6r squared plus 11r minus 6 equals 0. Now, you're not responsible for factoring out third order equations, even though you could use rational roots theorem and long division. But suppose I tell you this factors out as r minus 1 times r minus 2 times r minus 3 equals 0. Then you would find r equals either 1, 2, 3. So as easy as 1, 2, 3. And you would still say that the general solution is a e to the 1t, so a e to the t, plus b e to the 2t, plus c e to the 3t. So as long as you can factor out the auxiliary equation, you can find solutions to those higher order ODEs, at least constant coefficients.